All right. I realized looking back, watching the video that I just made, that I actually made some mistakes when I was explaining this to you. Not that it makes any difference. What I said there was correct, and you can do it exactly as I did, but it's how you state your hypothesis here and exactly what's going on in this model. I think it's an opportunity for me to teach you how to kind of lie with statistics, which is not what I want you to do, but you can see it'll be a good example of showing you how easy it is to confuse people. So what's really going on, like I said in the last video, what we're doing is chi-square measures how different these are. So for instance, 2449 and 2490 are different numbers. But are they so different that we could say that just by random chance they might be the same number? That's what we're saying. We're saying this is our model, this is the way we think reality really works. But we got these numbers. Are these close enough for us to think that they might really be the same number just by random chance, though we were off a little? Measurement error, if you're counting cows, if you remember that early video I made, did maybe like one of the cows get hit by a truck or something and therefore throw all my statistics off? Something like that. And we have to come up and see if our model is close enough to the number. So we're expecting this number, but we're getting this number. And so what we're doing here, and what I did not make clear, and that's why I'm re-saying this, is that we do have a stated hypothesis. And the hypothesis here, now remember, the hypothesis is more or less the opposite, or it's something different than the null. The null is something that excludes the hypothesis. All right, now if you know a little math, you understand what I mean by exclude. So your null hypothesis can be something really grand. All right, like my number is let's see. It always has to come back to numbers, though. Let me make that clear. A null hypothesis has to be usually something that's measured. And a null hypothesis might be something like, my number is not 7. Well, that means your number can be pretty much anything except for 7, which leaves it wide open. And that's the way you kind of cheat with one of these, with the statistics in a chi-square, is that you make your hypothesis something very specific, and so essentially almost anything is going to be correct. And in this particular case, what we're doing is our hypothesis is that these numbers are the same. And I did not state that correctly when I gave the first video. So these numbers are exactly the same. That is the hypothesis. And what we're doing is chi-squared is checking to see if these are close enough for us to say our hypothesis, how different are we from the model? Are we different enough for me to reject? You don't really reject a hypothesis. You do it in terms of the null. But our hypothesis, all right, which is normally you think this is what we're trying to prove, well, no, in reality, usually your hypothesis is something you don't want to have happen. So in other words, what we're trying to do here is our hypothesis is that these are exactly the same. And so we are going to ask this and state this in such a way, all right, that when we reject, all right, or I should fail to reject the null, all right, by being lower than this, we are going to be saying that the unknown, all right, is not exactly where BW is. That's actually what we're saying, which is, like I said, it takes time to understand how these questions are worded. So our hypothesis, if this is our null, our hypothesis is that the unknown is BW. Our null hypothesis is that it's scarbarous, which is located a distance away from BW. So it is tough. So in fact, they actually stated this incorrectly. Now that's when I realized, oh, this needs to be reworded, and it's an opportunity to say, really, what we're proving here in failing, we're not proving anything. Let me rephrase that. We are not proving anything. When we fail to reject the null, all right, we're saying that we are not on BW. We actually, this is misstated by saying your unknown is scarbarous. All it's really saying is we're left wide open to, we're open to the idea that it is perhaps scarbarous. All right, that is all this number is saying. This number, by being less than 7.82, all we're really saying is that, yeah, it's far enough away from BW for me to think that that maybe it's not exactly BW. So in other words, we aren't proving anything. All right, we are not proving that scarbarous is BW. All right, or I mean, we're not proving that the unknown is scarbarous. What we're saying is that the unknown is not BW. And so actually this is phrased somewhat incorrectly. This is acceptable for this class, and this would be acceptable for a genetics paper. But a statistician would actually have a problem with this, because technically all we're saying is that the unknown is not BW. That's all you technically can say here. But if it's not BW, you're still open to the idea that it could be scabrous. So you realize we're not saying much here. And ultimately, the chi-square on this one, and in this genetic model, all it's saying is that the unknown is not BW, which really isn't that much. We're saying it's further away, so it's all we're saying is, well, according to these statistics, we can potentially say that it's scarbarous. All right, so I just thought I'd clear that up. So in a way, this model has some flaws in it. It is the most commonly used, and nobody would say anything about the way it's used. It's legitimate, but you could criticize the way that the null hypothesis is stated. All right.